This is lesson 35, characterization of parallel lines and the nature of solutions to a linear system. We are going to graph the system of equations on this grid. So the first equation, our slope, is 2 over 3. And our y-intercept is 4 and 0, 4. So let's graph that first. So we have 0, 4, which is here. And then we have, it's negative 2/3. Sorry. So we are going to go down 2 and over 3. And down another 2 and over 3. And we are going to graph that. So this is y equals negative 2/3 x plus 4. Excuse me. Our next one is slope is 4 over 6 negative. And then our y-intercept is negative 3 or 0, negative 3. So let us graph that one. So we have negative 3. And because this one's a little bit difficult to come down here, we can't really do that. So I'm going to go up 4, 1, 2, 3, 4, and over 6 to the left. 1, 2, 3, 4, 5, 6. And since we really only need 2 points, I can go ahead and graph that. And let me label that line. We've got y equals negative 4/6 x minus 3. And it says identify the slope of each equation, and what do you notice? Okay, the slopes are negative 2/3 and negative 4/6. And what I notice is they are equal. Now, the next thing it says here is identify the y-intercept of each equation. Are the y-intercepts the same or different? The y-intercepts are 4 and negative 3. Excuse me. They are different. And let me spell different correctly. Instead of with a D, let me put a T in there. Okay. All right. Now, number 2 says graph the system. Okay, so let's graph that as well. So here I have the slope for the first one. Okay, we have a slope of 2 over 1 with a y-intercept of negative 5 or 0, negative 5. And the second one, we have a slope of 2 and a y-intercept of negative 1 or 0, negative 1. So here we have negative 5, which is here. And we have a slope of 2, so up 2 and over 1. Up 2 and over 1. Up 2 and over 1. So let me draw that line. Okay. The other line starts at 0 and -1. That slope is also 2, so we go up 2 and over 1, up 2 and over 1. We can also go down 2 and to the left 1, because as always, I like to have 4 points. It's just what I'm used to. Makes for a nice, easy, and nice line here. And again, I need to label my lines, label my axes, which they are already labeled here. So let me label my lines. I've got y equals 2x minus 5, y equals 2x minus 1. It says identify the slope of each equation. What do we notice? Okay, the slopes are 2 and 2. They are equal. Okay. The y-intercept for each equation are -5 and -1. They are different. All right, so that being said, what do you notice about each of the systems that you graphed in exercises 1 through 3? Well, the lines graphed as parallel lines. What did you notice about the slopes in each system? Each time, the linear equations had the same slope. What did you notice about the y-intercepts of each equation in each system? The y-intercepts were different. Okay. So in conclusion, okay, 2 distinct nonverbal lines in the planes are parallel if they have the same slope. If 2 distinct nonverbal lines have the same slope, then they are parallel. Okay, so now suppose that they have, excuse me, suppose that they have a pair of parallel lines and a coordinate plane. In how many different places will those lines intersect? They will never. Intersect. Suppose you are given a system of linear equations that graph as parallel lines. How many solutions will the system have? there will be no solution. Write an example of a system with no solutions. Okay. Okay. Next. What we want to find out is how to recognize when the lines defined by the equations are parallel. Then we would know immediately that we have a system with no solutions without graphing. A system can easily be recognized as having no solutions when it is in the form of x equals 2, x equals -7, or y equals 6 and y equals -15. Why is that so? Well, that's because x equals 2, x equals -7 are vertical lines, are two vertical lines. Okay. Y equals 6, y equals 15 are two. Let me write it this way, guys. I don't like to leave that word like that. Two, oh, sorry, are two horizontal lines. Okay. We want to be able to recognize when we have a system of parallel lines that are not vertical or horizontal. What characteristics did each pair of equations have? Okay. Well, they have the same slope. But different y-intercepts. Right? So that's what they have. Okay. Next. If the equations had the same y-intercept and the same slope, what would we know about the graphs of the lines? Well, let's investigate that. Let's graph the following system of equations. Well, the first one, let's graph with our x and y axes coordinates here. Well, let's do them both this way. So for this one, I'm going to put x plus 2y equals 2. So I'm going to say x comma 0. So for 0 here, x plus 2 times 0 equals 2. X plus 0 equals 2. So x equals 2. So putting it into the other equation, I'll put it in, yeah. So x is 2, 2x plus 4y equals 4. You know, now let's do it the other way here. So 0 comma y. So x plus 2y equals 4. 0 plus 2y equals 4. Divide both sides by 2. And y equals 2. So we have 2 comma 0 and 0 comma 2. Okay. So we have 2 here. And we got 2 here. So let's draw that. Let me fix the light. All right. Now for this equation here, I'm going to solve for y. So I'm going to subtract 2x from both sides. And I get 4y equals negative 2x plus 4. Divide by 4. They're nice. All of them, 4 goes into all of that. So y equals negative 1/2 x plus 1. So my slope is negative 1/2. My y-intercept is 1 or 0, 1. So and actually, guys, sorry I did that wrong. Let me redo it. Sorry, my mistake. My mistake. I'll redo this my way. Sorry, guys, I did that wrong. I don't know what I'm doing today. Sorry, guys. Sorry, guys, my bad. Okay. So let's do this first. So I got 0, 1. And now we've got negative 1 and 2. So negative 1 over 2. Negative 1 over 2. So let's do that one first. So now, Mrs. Smythe is losing her mind. The x one is right. So we've got x comma 0. Okay, so x plus 2y equals 2. So x plus 2 times 0 equals 2. So x equals 2. So we've got 2 comma 0. And now for x plus 2y equals 2 for 0 comma y. So we have 2y equals 2. Divide both sides by 2. We have y equals 1. So 0 comma 1. Mrs. Smythe is losing her brain, guys, and I apologize for that. Sorry about that. So that is what we need to do. Okay. So now, all right. So now that we graph these, what do you see? Well, if I plot these, I get 0, 1, which is here. I get 2, 0, which is here. And then when I graph these, if we notice, guess what? They are the same line. Okay. So we can also check if a system of equations has infinitely many solutions. By checking to see if the equation are multiples of each other. Okay. So now, it says write an example of the equation with no solution. All right. And I think what they mean is with multiple solutions, guys. Sorry. All right. And the way that we could tell here, and actually without graphing this, if you notice this, okay, what I could do with that is I could pull out that 2. Okay. And it's the same as this equation here. Okay. And it's basically the same. It's a multiple of this. Okay. So here, if I give an example down here, and I say x plus y equals 7, a multiple of that would be 4x plus 4y equals 28. And it would be the exact equation when I go and graph it. Oops, sorry. When I go and graph it. Okay. So next. It says write a system of equations that has no solutions. Okay. So in other words, same slope and different y-intercept. Okay, well, y equals 3x plus 1, y equals 3x minus 2. Okay. It says write a system of equations that has 2, 1 as a solution. Okay. So how about y equals 3 over 2x minus 2, y equals minus x plus 3. How can you tell if a system of equations has a solution or not graphically? Well, if the lines intersect. Then there's one solution. No solution. If they are parallel. It says, does a system of linear equations shown below have a solution? Answer is yes. And that's because the slopes are different. Okay. Next. It says Jenny babysits for 2 different families. One family pays her $6 each hour and a bonus of $20 at the end of the night. The other family pays her $3 every half hour and a bonus of $25 at the end of the night. What type of solution does this system have? Well, the first family pays her $6, okay, for every hour and a bonus of $20. The other family, okay, $3 every half hour, so that would be $6 an hour, plus $25 at the end of the night. What type of solution? No solution. They are parallel lines. the slopes are the same. Okay. Next, it says, does the system of linear equations shown below have a solution? Okay, well, here we've got to look at this and check. Well, if I look at this, notice what we have here. We have a multiple. If I multiply this equation here by 3, okay, I get this one, which means yes, it has a solution. It has multiple. The first equation is a multiple of the second. Okay? And therefore the same line. Okay? Okay, last. All right. It says, can we show the same type of solutions by solving the equations algebraically? Yes, we can. So the first one here, okay, by substitution, we have 2x minus 5 equals 2x minus 1. Subtract 2x to both sides. Negative 5 equals negative 1. Therefore, no solution. Okay. The next one, we can multiply the top one by 2 and get 2x plus 4y equals 4, and 2x plus 4y equals 4, and show same equation. Infinitely many. Actually, guys, we got to prove that, sorry. So this is the same. So we're going to multiply this actually by negative so that it ends up being 0. So let me redo this. So when I multiply by negative 2, I get negative 2x minus 2y equals negative 4, because we have to prove it algebraically. So gone and gone. So 0 equals 0. So infinitely many. And the last one we have, okay, again, substitution. So substitute in. So we have 2 times 8 minus 6y equals 7. So we have 16 minus 12y equals 7. Subtract 16 from both sides. Oop, I forgot to add the 3y, guys, sorry. Making a mess of this today. All right, so 16 minus 9y equals 7 minus 16. So minus 9y equals minus 9. y equals 1. So x equals 8 minus 6y. X equals 8 minus 6 times 1. 8 minus 6. So x equals 2. So our solution is 2 comma 1, and therefore we only have one solution. So that ends the lesson.